Okay, for question two hashing practice, before we go further into the question itself, let's consider some useful tips. First of all, as specified in the question, that is integer colon hash code returns the integer's value. What this means is that the bucket to input key value, like the bucket number itself, will be determined by the following, which is you take the integer key and modulus by the number of buckets. And as a refresh x modulus y, it will return the remainder of x divided by y. Secondly, to insert a key value pair, if a mapping with key k already exists at the target bucket, the mapping, like at the mapping itself, the value will get updated to the value of the latest insertion. In this case, it will be just like whatever value it has in the mapping, but that gets updated to value v. Okay, cool. So let's dive into the question. Before everything else, as shown in the diagram, the number of buckets that we are dealing with is 5. Okay, so the first command, we are asked to insert this key value pair of tree and monument into our hash map. So 3 modulus 5 will return 3. So we will place this key value pair at bucket 3. It will look something like this. Okay, cool. For the second command, 8 modulus 5 returns 3 again. So bucket 3 it is. Okay, however, for the third insertion, we see a key value pair of 3 worker. For the key 3, we already did the same modulus operation in the first insertion call, and we know that any key value pair with the key of 3 will be inserted into bucket 3. So by tip number 2, we see that since the mapping with key 3 already exists at bucket number 3, which is the target bucket, the value of such a mapping with key 3 will be updated to the latest value. So this means that monument will get updated to worker. Okay, cool. So on the fourth insertion, we have 5 modulus 5 will return 0. So this will be inserted at bucket 0. Okay, for the last insertion call, we have 13. 13 modulus 5, we get 3 again. So this will be inserted at bucket 3. Okay, in this question, like notice that at bucket 3 there are 3 collisions occurring. However, since like this question doesn't specify any resizing operations, so we can just like not consider for load factor and the subsequent resizing operations for now. Okay. So for the second sub question, suppose a resize occurs, right? Which we double the array, the bucket array to size 10. So what changes? Okay, Like the tip to this question is that to only consider cases with key that is larger or equal to the previous number of buckets, which is number 5. So the cases that we need to consider are the second insertion call, the fourth insertion call, and the last insertion call. Alright, so we will now change the modulus to like 10 and see what happens. Okay, for question B, I'm gonna use yellow as its color code to reflect the new number of buckets, which is 10. Okay, so 8 modulus 10, we get 8. So this means that the key value pair of 8 strand will just be inserted at bucket 8. Okay, 5 modulus 10, we get 5. So 5 granary will be inserted at bucket 5. So at this point, we can see that the key value pair of 8 strand and 5 granary, they will no longer be at bucket 0 and bucket 3 respectively. Okay, cool. Okay, so let me backtrack. Just to be clearer, like the key value pair of 8 strand will no longer be at bucket 3, but it will be at bucket 8, right, in the new case after resizing. While the key value pair of 5 granary will no longer be at bucket 0, but it will be at bucket 5 after resizing. Okay, cool. So for the last insertion called 13 modulus 10, we will get 3. So this means that the key value pair of 13 worker, it stays at bucket 3. So after resizing, like the new hash map structure will look something like this. All right, that's it. Thank you.
So going on to part 2 of this question, it asks us, what does it mean for a hash code to be valid? So there are a couple constraints that a hash code has to satisfy to be valid. One thing it has to satisfy is that it is consistent. What this means is whenever you call the hash function or hashing function on an object, on the same object, it will always return the same hash code function regardless of when in the program's like runtime it is. This is assuming that like object attributes have not changed at all. So basically, as long as you're calling hash code on the same object, it will return the same hash code. And this is important because, like I said before, a hash code is essentially an ID for your object or your element. And in order for ID to be valid, it has to be consistent every time. You would always have to have the same ID for the same object in order for it to work. And another thing for a hash code to be valid is that it has to follow the equality constraint. What this means is if two objects are equal, using equals, if you call like equals object method and two objects, and the return, they should have the exact, their hash codes should essentially be equal as well. So basically it's saying if we're given the same object twice, it should have like the same hash code, the same ID, which makes sense. And there's an additional not constraint, but it's an additional idea that makes a hash code good. So consistency and equality constraint are what seem to make a hash code valid. But in order to, another thing you should keep in mind when creating hash code is to avoid collision avoidance. Basically what a collision is when you have many different objects with the same hash code. So basically this becomes a problem because if we have many different objects with the same hash code, this would end up putting them all in the same bucket and making the linked list in that bucket extra long, which defeats the whole point of having like different indices for a linked list in the first place. So as a result, a good hash code would avoid assigning the same hash code to different objects. So those are the 3 things we should think about when making a hash code valid and making sure it's good. So now we can use those 3 things to help us with question 3, which asks us which of the following hash codes are valid or good. So let's walk through this class first. So we're given a class called point, and inside there's x, y variables, and they're int, and that's a counter called count, and it's set to 0. So whenever you construct a new point object, it sets its x to x, its y to y, and it increases the count of the class by 1. So let's go through the different hash code methods and see if they would return the right value. So first we have a public void hash code, and then after this it prints out the sum of x and y. So immediately we should know that this is invalid because it is has a void return type. A hash code method is supposed to return an integer. It's supposed to take in the user object and generate an integer from it. However, it's not generating an integer because it's only printing out an integer rather than returning it. So this would not be a valid hash code method. So moving on to the next method, we have a public int hash code, and it generates a new random object every single time and returns a randomly generated integer as a hash code. So let's go through the 3 things we talked about before. Consistency, it's consistent, quality constraint, and if it's collision avoidant. So the first thing we have to check if it's consistent. So if we called hash code on the same object twice, we return the same hash code. Okay, the first time we call it, will return a randomly generated integer. Second time will also be a randomly generated integer. This does not ensure that it will be the same integer both times. As a result, it is not consistent and cannot be used as a valid hash code. So going into part C, we have another hash code method that returns an integer, and it's a sum of the x value and y value of the object. So if we call hash code on an object twice, as long as the x and y have not changed, it will always return the same hash code because summing x and y will always result in the same number. So it falls into the consistency constraint. If we go to a quality constraint, if we had 2 objects that were equal, would it return the same hash code? If 2 objects were equal, they would have the same x and y value. So as a result, they would both have the same hash code. That means it follows the equality constraint. So this is a valid hash code. So let's do additional check to see if it's actually good. So let's see if it avoids collisions. So basically what we want to see is we want to make sure that this hash code would not generate the same hash code for 2 separate objects. So pretend we had a object of attributes 1 and 2. So x would be 1, y would be 2. So if we call it hash code on this, it would do 1 plus 2, and it'll generate a hash code of 3. However, this hash code is not unique. You could easily create another object that has the same hash code despite having different x and y parameters. So if we create another point that has x equals 3, y equals 0, if we did called hash code, it also do 3, even though they're completely different objects. So as a result, this method would create collisions and therefore is not good. Let's go to the next hash code method. So basically, so this one is returning in the number count as the hash code every single time. So would this hash code be consistent? Count is basically a counter for the number of objects created. So it increases every single time we create a new object. Therefore, it is not consistent because if you call it once on an object and then you create a new object and call again on the same object, will return the original hash code plus 1 because the count has increased. So since it count changes throughout the run of the program, we know it's not consistent. And for the last point, we are given a hash code method that returns 4 every single time. So is it consistent? So if we called hash code twice on the same object, it will return 4 both times because it's the only thing it can return. So it is consistent. And if we were trying to check if it follows an equality constraint, if we had 2 objects that are the same, they would both have the same hash code because there's only one possible hash code. So it follows both attributes. So it is a valid hash code generation method. However, let's check if it's collision avoidant. So in order to be collision avoidant, it has to assign different hash codes for different objects. However, since it's assigning 4 to everything, it is not collision avoidant because it's putting everything in the same index, which defeats the whole purpose of having an array of linked lists. So as a result, it is not good. Hopefully this helped you understand hashing and how to generate good hash codes better. And that's it for today, and thank you for watching.